I was going to kill a man. I was going to kill a man. I have teaching this class as my alibi. What is it? No.
You left your mic out, so that doesn't work. But
Oh.
turn off the mic for you when you left.
Oh, I was hoping it would capture the sound of me making coffee.
You was hoping that it was still
Oh, I remember that unfortunate episode with the what's his face there, the Jinx or whatever. Well, like he had his mic on in this interview, and then like he walked into the bathroom or something. He's like, oh no, now they all know I'm guilty or whatever. Remember? I mean, this is big news, like half a year ago or something. Oh, you guys don't watch the news. What am I talking about? Robert Hearst, was it? No. He's long been suspected of killing some bunch of people somewhere. And I don't know, it was 60 Minutes or... And I think somebody doing like a documentary of it or something, of his life, and he said too much, and now I think he's on trial. I'm not sure if the trial's happened yet or not. Anyway, who cares? Let's get back to something interesting. Math. Okay, so any ideas? Take the integral. Now, why would we do that? Right. And so if we integrate, say, from time 0 to time 1, v of t dt, that's the same as integrating, well, I mean, there's different ways you can look at this. One way you can look at it is the following. So this is, well, let me just get straight to the point. That means that the position is the antiderivative for the velocity, right? So this is just s of 1 minus s of 0. Right, exactly. So we can calculate the integral of the velocity directly as follows, right? Integral from 0 to 1, what do you tell me, t cubed? T squared plus 3 dt. And you told me that that was 1/3 t cubed plus 3t. And then we have to evaluate from 0 to 1. We get 1/3 plus 3, or approximately 3.33 miles. I know, right? It's kind of sad, isn't it? If it was yes, sir.
Do you just ignore that it could be a constant?
Well, so the constant in the antidifferentiation, when you subtract the remember the fundamental theorem of calculus says that the integral of f of x dx from a to b is equal to f of b minus f of a, you know, where f prime of x is equal to f of x, right? So what if I did f of b plus c minus f of a plus c? See, if I add a c to the antiderivative, I'm still back to same thing again. So the adding a constant, it was important for us when we were solving initial value problems, but when it actually comes to calculating in definite integrals, it doesn't matter. So the point of this problem is that if you want to find the distance traveled, right, if you want to find well, more specifically, the displacement, then we integrate the velocity over the time period, and that gives us how far it went. Any questions? So I think there's a problem like that in your homework. I just wanted to talk about it here a little bit. Okay, so our next problem is the problem of calculating areas bounded by graphs. So essentially, the story is something like this. If you have some function, say y equals f of x, right? And then you have some other function below y equals g of x. You'd like to find the area between those curves. Let's suppose that they intersect at like x equals to a, and over here x equals to b. How can you find that area? It turns out the answer is simply that the area is equal to the integral from a to b of f of x minus g of x dx. So this is what we want to do. We want to look at a region, identify the top curve, identify the bottom curve, right? And then we integrate the top minus the bottom over the appropriate region, and that gives us the area. Now, could you understand why this is? Like, if you think about it, I guess if these are both positive, right, you could kind of understand it easily. What's the integral? If this is the x-axis down here, right? The integral under f would be what, like the whole thing, right? Sorry, shading. So that would give you the integral of f of x from a to b, right? That would be too much. To get rid of what you don't want to count, you would subtract the integral of g of x, right? Which would be this piece down here, right? Like the integral of g of x from a to b would be this red area. So if you take the red area and subtract it from the total area on the top curve, that should give you the area between the curves. Does that make sense? So if we integrate f of x minus g of x, that should give us the area between the curves. Let's work some specific examples, though. That I think that's the way to go here. So here's a standard example. Find area bounded by y equals to x and y equals to x squared. So these problems are all about graphing, all right? We've got to understand how to graph functions. That's why a lot of your homework is just to try to kind of build up your graphing, help you to remember how to graph things. And because I know some of you are probably a little bit rusty, right? We haven't graphed much since that other course, which might have been a couple of years ago for some of you, right? So, just a second here. Let me get something out. Oh, you did turn the mic back on, right? Yeah. Okay. Thank you. So guys, how would we, when you're thinking about the graphs of two curves, what do you got to think about? It's the most important thing to figure out. Is intersection, right? Where do the graphs that intersect? So how do you find intersection points? I think of it this way. Just set y equals to y, right? We have two different y's, the y for x squared, the y for x, so set them equal. And that gives me x is equal to x squared, right? That equation has to be true for a point which is in common to both graphs. The intersection points between two graphs is where both of their equations hold true. So this gives me x squared minus x equals to 0, which gives me x times x minus 1 equals to 0. So you got either x equals to 0 or you've got x equals to 1. Those are your points of intersection. Is there something mysterious? You look perplexed.
I just think that it's so simple, but I've never thought of that.
Oh, this way?
Or setting them equal to each other, saying, well,
Oh.
let's find out where both equations are at the same time.
Right, but that, I mean, if you think about it, that's how to find the points of intersection. I mean, what is a graph? A graph is a set of all points in the plane where y is equal to f of x, right?
Yeah.
So if I want to find out where y is equal to f of x and where y is equal to g of x, I just set f of x equal to g of x, and that will tell me where they meet.
I know we've done it, but I never thought
Yeah.
why it would
Ah.
use that.
See, someone should have said that.
They just like put everything on those areas.
They just said do it. Dance monkey dance. Oh, okay, so the graph here, you really have to draw the graph in order to understand what you're doing. So the 2 points of intersection are the origin, right? And the point 1, 1. How do I know it's the point 1, 1? Well, they're both on the graph y equals x, right? So y equals x. So x is 0, y is 0, x is 1, y is 1. Those are the points. Now, the line y equals x, that's easy. I think we can all do that. And the parabola y equals x squared, I think that's also easy. I think we can all do that. We agree? I think hopefully none of you are confused about I mean, definitely x squared is below. How can you decide whether the parabola is above or below the line if for some reason you had a moment of doubt? Plug in a point, right? What happens if you plug in like a half? What's this point if we look at the halfway point? 1/2 what? 1/4, right? It's on the square, y equals x squared, right? Okay, so we're trying to calculate what's the area of this little lemon wedge kind of looking thing here. Here you go. We just have to integrate from 0 to 1. So the area is equal to the integral from 0 to 1 of x minus x squared dx. And then we do what we did last time, right? This is 1/2 x squared minus 1/3 x cubed, parentheses, evaluate from 0 to 1, my favorite kind of bounds. That's 1/2 minus 1/3, otherwise known as 1/6. Now, a lot of your homework problems actually come with graphs, right? So you don't have to make the graph yourself. So, I suppose in fairness to you, some of the questions I'll ask on the test, I'll probably only ask like 2 of these. Maybe I'll probably just be like one of these kind on the final. Maybe I'll have one of these kinds on the final and another one where I give you the graph and you have to calculate the area. I mean, if I give you the graph, it's much easier, right? I think the hardest thing here actually is making the graph, right? The integration, is this hard? I don't think it's that hard.
How do you do it just by the graph?
Oh, I can't do it just by the graph. That's the kind of, if I could do it just by the graph, I wouldn't teach calculus. What I'm saying is creating the graph is a hassle. Finding those points of intersection involves algebra, which is dangerous unless we're really good at algebra. We're not. Well, some of us are. Well, I don't know. Algebra is dangerous. Let's just say that. So here's one of your questions. It's got like this line, and you're given that the line is y is equal to x minus 2, and you've got a graph, y is equal to the square root of x, and you're asked to find the area of the shaded region. Let me shade the region. So let's find the area of that shaded region. How do we do it? I mean, it's a little bit easier than what my first example was because they gave us a picture of it. On the other hand, it's still kind of, they haven't labeled the point of intersection though. We still have to find that, right? And you need to find that because that tells you what range you have to integrate over, right? We're going to have to integrate from x equals 0 to x equals to blank. Fill in that blank. You know, what is that point of intersection? How do we figure it out? We have to set y equal to y, right? Which in this case gives us x minus 2 is equal to the square root of x. How do you solve that equation? I will eventually stop coughing. Next semester. Hopefully before I go to Disney World over break, I don't know. All right, so square it, right? The natural enemy of the radical is a square. So square both sides. And we get x minus 2 quantity squared is equal to the square root of x quantity squared, right? So on the one side, I've got x squared minus 4x plus 4. On the other side, I've got x. Since this is a problem that we've asked you in homework, I sincerely hope that this has nice solutions. Otherwise, I'll be annoyed. X squared minus 5x plus 4. Hey, do we need? I mean, generally speaking, you shouldn't be scared, right? Because it's a quadratic equation, right? So you can always use the quadratic formula to find the solutions. But hey, we don't even need that here. We can do what? Factor, right? 4 and 1, yeah. X minus 1, x minus 4. Huh. That is weird. What? No. Well, that ain't cool. What? Uno momento, por favor. What? What? Oh. Oh, that's funny. That's funny. Oh, this is actually kind of a neat little problem now that I see it. This isn't wrong. X equals 0 gives us two solutions, right? X equals to 1 and x equals to 4. One of these is extraneous. I've often said that if I was a rapper, I would go by the name Extraneous G. Because I'm not even in the solution set. Yes, what? What's that? Yes. Yeah, so what's going on here is this sideways parabola is the graph y squared is equal to x. The algebra we did here is insensitive to the difference between the top half is what we looked at, right? This is y is equal to the square root of x. The lower half here, though, right, this guy down here is y is equal to minus the square root of x. That minus the square root of x intersects the line down here at 1. And that's why we're picking up this 1 down here. But that obviously is extraneous, right? That's not the one we're looking for. Okay? So we have to do algebra guided by common sense. So common sense says 4 is what we're looking for. Are we good? And then what? Calculate the area, we integrate. So we have to integrate from 0 to 4, what? The top y minus the base y. What is the top y? Right, the square root of x. And then the bottom one was minus, and guys, parentheses are your friends here. Like, don't desert your friends. Your friends need you. You need them. See here, x minus 2, like that, dx. There's a life lesson in this problem. Be good to your friends. So it's very important to put these parentheses there, otherwise you'll be very tempted to make that minus a minus 2 a minus 2, but it's supposed to be a plus 2 when you distribute the minus, right? Not paying attention to that will make it wrong. Are you guys with me? So integral from 0 to 4, square root of x minus x plus 2 dx. And now we're back to our happy place. The integral of the square root is 2/3 x to the 3/2. The integral of x is 1/2 x squared. The antiderivative of 2 is 2x. Fundamental theorem of calculus says I take this whole thing and I have to evaluate from 0 to 4, right? So I plug in 4 and then I subtract plugging in 0 to that thing, right? I evaluate at 4 and then subtract the evaluation of the expression at 0. What is 4 to the 3/2 power? Four to the 3/2 power is the same as 4 to the 1/2 power cubed, which is 2 cubed, which, as you just told me, is 8. So what I have is I have 2/3 of 8 minus 1/2 of 4 squared is 16 plus 2 times 4. 0 is just 0. And so what I got is I've got 16/3. That's minus 8. Oh, these cancel. So 16/3, yeah. Whew. Okay, that's what's in the answer key too. That's good. Just checking. Let's work another. Yeah. All right, so I'm going to work one more of these, and then I'm going to go on to what's known as integration by parts. That way, if you have some time over break and you want to, get a little bit further ahead in the homework, we'll have covered a little bit more, so you got more to chew on. If you want to avoid a conversation with your family, you can be like, "Oh, I'm sorry, Mom, I've got to do my calculus homework." It's good, it's a good out. Sorry, what am I talking about? You guys want to talk to your family, right? Yes? Okay, good. Very good. That's what you should say. We're on camera. Let's see here. So, let's see here. X, Y. I'll try to recreate this graph in all of its splendiferousness. You've got this cubic, like that. You've got this shallow line, y is equal to minus 1/2 x. Here's y is equal to x cubed. And then this top line, like here, which is y is equal to x plus 6. We want to find the area of the shaded region. Once you understand one of these, you can kind of do all of them, but, well, up to the algebra of finding the intersection points, right? You see what we're going to have to do here. Oh, this one's a little bit sneakier. You see, I'm going to have to divide this into two pieces. Do you see why? Let's say, I need to come up with some labels for these. I will find these points here in a second, but until we know them, I just want to kind of tell you what's going to happen. Let's call this point A. Let's call this point over here C. So if you look at it, between A and 0, we have that the top y is what? And the bottom y is what? Top y is x plus 6. See it? And the bottom y is minus 1/2 x, right? And then, but from 0 over to this other point, C, what's the top y? Well, it's still x plus 6, isn't it? But what's the bottom y? Yeah, it's x cubed, you see? So we're going to have to, what we're going to do is we're going to divide and conquer. We're going to calculate the area of the left half, and we're going to calculate the area of the right half, and we're going to add them together. Does that make sense where we're going with this? Unfortunately, one integral isn't going to quite do it here. We need to break up into two integrals. So we'll do the green and the red separately. Okay, so the first thing we got to figure out, though, now that we have the big picture in mind, we got to figure out what A and what C are, right? How do you figure that out? For A, we should set what? We should set minus 1/2 x equals to what? It's the intersection of the lines, right? It's where the y for the lines are both true. So we have minus 1/2 x is equal to x plus 6. Does that make sense? So, I mean, solve this however you like. I'm going to multiply by minus 2 because I hate fractions. So that gives me x is equal to minus 2x minus 12, which gives me minus 3x is equal to minus 12, which gives me that x is equal to minus 12 divided by minus 3, which is otherwise known as 4. Oh, man. What? Oh, man. Oh, man. Thank you. It's like, this doesn't make any sense. Yeah. This is a plus 3x. I was like, that does not make sense. Thank you. So minus 4. So apparently A is equal to minus 4. Right? Now how do we figure out the point C? Actually, I'll do it down here. We got to solve x cubed, well, minus, no, wait, what? X plus 6, right? Ooh, x plus 6 equals to x cubed. Ah, I'm scared. Two works. 2 plus 6 is equal to 2 cubed. Therefore, x is equal to 2. Guessing. Have you heard of it? We can't guess. You guys forgot. Before you learned algebra, there was guessing. I'm just bringing it back. You want a method to factor a cubic. Is that what I'm hearing? I mean, so you're asking the question really, and it's understandable what you're asking, which is where in the world did I come up with 2? I came up with 2 by the principle of book problems be easy. As a general principle, if an algebra problem is in a freshman level math course, the answers should be integers. So you got choices: 0, 1, 2. 0 didn't work. 1 didn't work. 2 worked. That's my thought process. But yeah, I don't know. I mean, how do you factor a cubic? There are some answers I can give that are more serious, like you could plug in a point and get a negative, plug in another point and get a positive. If it changes from negative to positive, then somewhere between those 2 test points, there must be a place where it crossed. But like honestly speaking, guys, I tried an integer. And there is why this is not a great test question, because it involved that step, right? If I was to put this on the test, I would probably give some kind of olive branch, like, I don't know, this. Okay. See, all I have to do is label that point, and it makes it a reasonable question. Okay, anyway, now that we've got that, we have to calculate the integral from -4 to 0 of x plus 6 minus a minus 1/2 x dx plus the integral from 0 to 2, apparently, of x plus 6 minus x cubed. So this is actually what? The integral from -4 to 0 and, what was that, 3/2? 3/2 x plus 6, right? That was a lot of writing for that. I don't know if I really needed to do that. Agree? Disagree? All right, well, anyway, I'm going to go on. So that's 3/4 x squared plus 6x. I evaluate from -4 to 0. And then over here, I've got 1/2 x squared plus 6x minus 1/4 x to the 4th, and evaluate from 0 to 2. Be careful with the bounds. Like this one, the 0 is the upper one, right? So the structure here you have is a little bit different than the one we've looked at. This one is like 0, right? Minus parentheses 3/4 times -4 quantity squared plus 6 times -4. Right? And then over here, plus 1/2 of 4 plus 6 times 2 minus 1/4 of 2 to the 4th. What does this give? I mean, this gives us oh, 36? Because the 4's cancel, so I'm like -12 minus 24 is -36, minus a minus 36 is 36. And then over here, excuse me, 2, that's 2 plus 12 is plus 14. And then subtract, that's what? 16 divided by 4 is -4. So it looks like I get 46. Oh, bummer. That is not the answer. All right, where did I make a mistake? But the thing inside the purple parentheses is negative because minus 4 goes into... Oh, there it is. Look at that. Look at that. This is what? This is not negative. This is 3 times 16 over 4. 48 divided by 4. This term is 12. 12 minus 24 is minus 12. This 36 should actually be a minus 12. It should be 12. I think that's the mistake. Now, 12 plus 14 is 26. 26 minus 4 is 22. That's the answer. Yeah. So that was the mistake. Does that make sense? I mean, I hope you see that the steps here are pretty straightforward, right? If we understand the calculus we did last class, you just got to identify the top curve, identify the bottom curve, identify the points of intersection, and integrate the difference. That gives you the area. Simple as that. These are actually pretty fun. So, all right. Excuse me. Stupid cough. I am now going to talk to you about another method of integration, so-called integration by parts, often abbreviated IBP, integration by parts. All right, so let me just kind of show you where this comes from. If we look at the derivative with respect to x of a product of two functions, say u and v, what do we get? We get du dx times v plus u times dv dx. Product rule, right? So that's point number one. Point number two I would make to you is that if we integrate df, we get back f again. And also, just more generally, I mean, well, perhaps this is a better way, or maybe this is a better way to look at it. If we integrate df dx times dx, we get back f again. Okay? That's essentially the definition of the indefinite integral. Okay, so what? If you take 1, and let's say we solve for u, v du. Let's solve for v du dx is equal to d dx of uv minus u dv dx, right? All I did was just move. So you just take this, right? That's from 1. and then just integrate with respect to x. And we have the integral of v du dx times dx is equal to the integral of d dx of uv dx minus the integral of u dv dx dx. Just integrate that expression excuse me, with respect to x. And what does this give you? This is just u times v. Right? That's just uv. And if you think of a u substitution and a v substitution, right? Think of a u substitution and a v substitution. We can even rewrite the other two things more compactly as this. The integral of v du is equal to uv minus the integral of u dv, where I'm making a v and a u substitution on the sides. And there you go. That's the integration by parts formula. So in order to do integration by parts, you have to identify the u and also the dv. So here's the algorithm. One, identify the v and the du. Two, calculate the dv and u. And three, use that the integral of v du is equal to uv minus the integral of u dv. And that will sometimes trade you an integral that we don't know how to do for one that we do. Let me show you the most famous example of this. Suppose we wish to integrate x times e to the x dx. So you notice there's some things we can notice in this algorithm if you study it. How do you get from du to u? You integrate. The integration of du is equal to u. So whatever I'm selecting for my du, it better be something I know how to integrate. Right? So what we'll do here in this example is this will be the du, and this will be the v. So that's my choice here. V equals to x, du is equal to e to the x dx. So I usually make a little box over here to the side to organize my thinking. If v is equal to x, then dv is equal to what? Come on, guys. You can do it. You can do it. No. What? Yes, dx. dv is dx. And what about u? U is equal to what? What's the integral of e to the x dx? E to the x again, yeah. So there we did step 2. We calculated dv and we calculated u, which we got from differentiation and integration. And now we apply the integration by parts formula, which will give us u times v, which in this case is x, well, I guess writing it in order, e to the x times x, minus the integral of what? U dv, which would be e to the x times dx. Hey, check it out. So this is x, e to the x. I like to write the x first, minus e to the x plus a constant, Voila. There you go, integral of x e to the x. That's one we couldn't do before just now. Well, some people find this stupid stupid rule helpful. The ate. This stands for log, inverse, algebraic, trigonometric. What is a trigonometric function? Exponential. This is the more or less the choice of u in integration by parts. Part of this advice is, of course, meaningless to you, as we have removed the part of our brain that does trigonometry in this course. Sorry, it still stings. It still stings. I don't know. All right, so for example, if I tried to do something like integral of the natural log of x dx, which, by the way, is something else we did. Notice before we knew that the integral of 1 over x was natural log of the absolute value of x, right? We had that before. But at no point have we figured out what the antiderivative of log is. Can you guys tell me what the antiderivative of log? What function can I differentiate to get logarithm, the natural log? We don't know yet, but let's figure it out. So here, what this says is what you do is you make this the u, and you make dx the dv. I mean, that's kind of your only choice here, because you don't know how to integrate anything there except for the x, right? So u is equal to the natural log of x, dv is equal to dx. So this gives me du is dx over x, and v is equal to x. I did step 1. I did step 2. Now I'm going to do step 3. I'll write it down symbolically. uv minus the integral of v du. Sometimes it's helpful to write it down symbolically. I probably should have done it symbolically last year. You guys would have followed this better if I had written one more step above this, which was uv minus integral of v du. That's what I did, Especially as the problems get more complicated, it's not a bad idea at all to write down the sort of blank template and then fill it in. So what is u here? U is ln of x. What's v? X minus integral of what? V, which is x. What's du? Dx over x. Well, isn't that convenient? See what happened there? The x is canceled. Which is awesome. And so now we have x ln of x minus x plus a constant. Bam. There's the integral. Integration by parts works really good for me because I've done nothing but math my entire adult life. You guys, you're still learning calculus. It makes this seem harder than it actually is. So if you have your basic differentiation and integration down pat, this actually isn't that bad. If you have trouble with it, it may be that your trouble is actually in the previous stuff. So, my best advice to you at this point in the course is, if you're having trouble integration-wise, go back to where we first introduced antiderivatives and work all the problems in that section until you're totally bored with them. It'll make the rest of the course so much easier. Anyway, any questions about this? Yeah.
I'm just curious as to what the is.
We need to identify the u and the v in order to...
Are those just variables that can vary?
Right, there, it's, let's see how to say it. Be a good analogy for what u and v are. It's kind of like once you can put something in a certain mold, you can do certain things to it, you know? Sorry, all my examples are very politically incorrect. You know. No, I shouldn't talk about putting animals to sleep. I don't know. I'm very bad with analogies. I mean, it's really just a template. Once you can identify something as the u and the dv, that means that you can trade this integral for these.
I just didn't know if there was a significance with the u and the v.
U and it's just a notation. I mean, you could this formula could just as well be written with the u and v swapped. It's symmetric in u and v. I can move that to that side and this to that side. It's totally.
Or I could use other letters.
Oh yeah. You could do integration by parts with like SpongeBob and Ghost if you wanted to.
Okay. All right, thank you.
No? Okay. All right, I'll skip my analogy about putting cats down. But all right. Sorry, I just don't like cats. Anyway, we could differentiate it and see if it works. If you take the derivative of this, what happens? You get natural log of x plus x over x minus 1. X over x is 1. 1 minus 1 is 0. You're left with natural log of x. You can pretty easily see that differentiating this gets you back to natural log of x, which is just amazing because, I mean, I don't know. This isn't that much work, and it allows us to find things that would be really a lot of trouble to do by guessing, right? I don't know. I think it's interesting. I mean, integration by parts does have a larger role to play in theoretical derivations and like in variational calculus, for example. Integration by parts is a critical step in deriving what are called the Euler-Lagrange equations, and those things fall at the base of most of modern physics. There's like a lot of interesting calculations which are built over this simple thing we did. Two natural log of x over the square root of x dx. All right, if you believe in Liate, I mean, you can take it or leave it, but Liate says we choose the log for the u first. So if we believe in the legend of Liate, we will choose u equal to the log and try to go with that. Now, if I choose u equals to log, what does that make? That means everything else is the dv. Once you make your choice of u, whatever's left over has to be the dv. So what's dv? If I make u equal to, this has to be identified with u dv. All right, so if u is equal to L on x, what's dv? Yeah, dv is 2 over the square root of x dx. Very good. Now du is easy. Du is dx over x, right? Now v is the integral of dv, which is the integral of 2 times x to the minus 1/2 dx, which is I mean, come on. What differentiates to 2 over square root of x? Yeah, it's I think it's 4. I mean, this is 2 times 2, x to the 1/2, right? In other words, it's 4 times the square root of x. it's easy to check that I'm right. If you differentiate 4 times square root of x, you get 4 divided by 2 root x, right? We know the derivative of the square root function is 1 over twice the square root, right? Right? Was everybody at the game? Stupid game. What is this, a school? I mean, it's a Thursday. Why are we having a game? Didn't they know? Today's for calculus. I gotta tell you. I know, but where is everybody? Oh, they already left for break? In the band. Cheerleaders and band members, that's no excuse. Calculus is first. I mean, calculus comes first. Come on. People. So disappointing. I tell you. All right, so uv minus integral. Sorry, I mean, it's kind of get boring after a little bit. It's always the same song and dance. Now, the thing that you're not appreciating enough from not doing it yourself is my choice of u. I state with absolute certainty, basically, that, oh, that's going to be the u. That will work. How do I know that's going to work? Remember I told you I've done nothing but math my adult life. It's that, you know? I mean, that's the thing that will shake your confidence with these problems is your choice of u. Like, you don't know the choice of u a priori before the fact. I mean, you got to make a choice and work with it. And it may or may not work. It's like u substitution. So there's some persistence that's required here. Anyway, I'm going to go on. So uv is 4 square root of x natural log of x minus the integral. Now v is 4 square root of x du dx over x. Aha! So what I have is 4 times the square root of x times the natural log of x minus 4 times the integral of x to the minus 1/2 dx. Which is what? 2 times the square root of x, right? So that's x to the 1/2 divided by 1/2. Where did the what? Where did the negative what? This one? Oh, because square root of x divided by x is equal to x to the 1/2 divided by x to the 1, which is x to the 1/2, minus 1, which is x to the minus 1/2. In short, the x in the denominator wins because it's bigger. So that gives you an 8, right? I bet they don't give you the really fun ones. Ooh. Something more fun. Kind of, sort of. Of course, you can combine these with definite integrals, right? Like this problem. What if I threw onto this the integral from, say, 1 to 2 of 2 times the natural log of x over the square root of x dx? How would that go? My advice to you would be to do the integration by parts, right? And then go back to, well, that's an antiderivative, right? So I can just do 4 times the square root of 2, natural log of 2, minus 8 times the square root of 2, parentheses, minus 4 square root of 1, natural log of 1, minus 8 times the square root of 1,